Now let's think about some different concept questions involving quadratics. Let's suppose a swimmer dives off a cliff and their height is represented by a quadratic function s of t, where t is in seconds. Well, if we were to draw that, let's say here's the cliff in green, and we're hoping there's water down here below. If you have a diver up here on top of the cliff and they jump off, that is part of a quadratic function. It's creating a parabola. So when you look at that picture, we can consider the water, the x-axis, that edge of the cliff as our y-axis. And if we were to draw it, it would look something like this. So in question 4, it says, when looking for their maximum height, what point are we looking for? So we can look at the picture. The maximum height would be up here. And what do we call that point? The vertex. So the vertex. And when looking for that maximum height, we look for the vertex. Then it asks which coordinate would answer the question. Well, we're used to it being h and k, but in the context here, t is our input and s represents our height. So s, or the output, would answer our question, because we want to know the height that he's at, not how long it took him to get that high. In question 5, it says, when looking for the height of the cliff, what point do we look for? Well, that's this point here. How tall is that cliff? So think of it in terms of your xy intercept. That's where it's going to meet. So we're looking at the y-intercept, which remember is of the form 0y. And which coordinate would answer that question, the height, would be the y value of the y-intercept. The last question, when looking for when they will hit the water, okay, so there's a hint there, when they would hit the water, not where, what point are they looking for? Well, here's the point where it hits the water. What point is that? That would be your x-intercept or t-intercept. Remember, your x-intercept has an x value and your y is 0. Which coordinate would answer that question? Then that would be your x coordinate, or in this case, it's your t, your input value, your t value. And your y value in this scenario is your s value, because that's your height. So sometimes if you're not sure, draw a picture. Even though it doesn't ask you to, draw a picture of the scenario, and then sometimes that can help you figure out what you're actually looking for. So let's do a couple of modeling examples. If a stone is thrown directly upward from a height of 30 feet, so you're up here at 30 feet and somebody throws a stone from 30 feet up, let's say they throw it off a building or something, and it has an initial velocity of 60 feet per second. It says the height of the stone t seconds after it has been thrown is given by this function here. They've given us the function. Even though they're describing 30 feet high, initial velocity of 60 feet, really all that's telling us, oh guys, there's an error here. This equal sign should be a plus. You don't have two equal signs in an equation. That's my bad. So they gave us the equation. So that first sentence just tells us how they came up with that equation. Okay, we're not even going to use that 30 feet or the 60 feet per second right now. So they've given us the equation. Thank you. Determine the time. Okay, so they're wanting to know t, the input, at which the stone reaches its maximum height. So that maximum height, that means we're going to be looking for the vertex, and they want to know the maximum height. So we're wanting to know both coordinates of that vertex. So let's do our vertex formula. So the h coordinate of our vertex, that's the input. That's going to be, again, the opposite of b over 2a. So we have the opposite of 60 over 2 times a negative 16. Now, if we were to keep this in fraction form where it would be exact, it would be, I believe, 15/8. But it does go into an exact decimal of 1.875 because we're talking about time and maximum height, it's usually a lot easier to go in terms of decimals. 1.875, let's see, H is our, oh, wait, okay, I don't want to confuse you guys. This is the H part of the vertex, the HK. So when we're dealing with the height and the time, that would be our T, and they're using H for the height here. So just to clarify, we're looking for the input value of time. So this would be, I believe, in seconds. And then we're going to find the K, or the height, which is the H of the 1.875 seconds. Which, if I put it in my calculator correctly, that is 86.25. And again, set the height, and we're dealing with feet. So you can say the stone reaches its maximum height of 86.25 feet in 1.875 seconds. The next problem, it says a local newspaper's quantity of subscriptions are linearly related to the price. This is represented by the equation Q equals negative 2,500 P plus 9,000, where P is the price in dollars. They want to know what price should the newspaper charge for a quarterly subscription to maximize their revenue. Well, this one's interesting because Q just represents the quantity, okay, how many subscriptions they're selling. So revenue is price, if you remember, times quantity. So that means price times the Q, but we want it in terms of only one variable. Well, we have the quantity in terms of the price. So to find that revenue function with respect to price, we're going to multiply price times the quantity function, 2,500 P plus 9,000. So we get a negative 2,500 P squared plus 900 P. And again, we're wanting to maximize this revenue. So we need to find the vertex. And again, our leading coefficient is negative, so it does in fact open down and have a maximum value. So to find the vertex, the input value, again, is still negative B over 2A. So in this case would be a negative 9,000. Sorry, I dropped a zero there. Would be 9,000. Divided by 2 over 2,500, negative 2,500, and that gives us 1.8. And if the P is in dollars, then it would be $1.80. So the newspaper should charge $1.80 to maximize revenue. They did not ask us what that maximum revenue would be. They just wanted to know what they should charge. Okay? So that's what they mean by asking for the price. What price should the newspaper charge? All right, let me double check since I missed a page on some other sections before. That's it for section 3.1. If you have any questions, don't hesitate to contact me or contact your instructor if you have any questions. Thanks, guys. Talk to you later. Bye.